All right, this lesson is a review of some basic circle information, starting with circle vocabulary and continuing on and dealing with the relationships between angles and arcs that are in a circle. And so one thing to keep in the back of your mind is a few of these relationships. For example, if an angle is at the center, the measure of the angle and the measure of the intercepted arc are equal. If the angle is at the edge, it's called an inscribed angle, and the angle is half the arc, or you could say the arc is double the angle. Please understand that even if one side of the angle is a tangent, this still counts as an inscribed angle, and it's still half the arc. So if this blue arc is 200, then this angle is 100. Now, if you have an angle that is inside of the circle but not necessarily at the center, then we need to deal with two intercepted arcs. And the relationship is angle equals arc plus arc divided by 2. And finally, if we have an angle that's outside of the circle, still we have two intercepted arcs, but the formula becomes angle equals arc minus arc divided by 2. And it has to be the big arc minus the small arc. Alright, so we're supposed to identify each of these things, and we have a word bank to help us. Line HF. Okay, line HF is a secant. Alright, because a secant is a line cutting through the interior of a circle. Point B. Let's see, where's point B? Oh, point B is the center of the circle. All right, point J. All right, there's point J. Point J is a point of tangency because I see the tangent touching. Okay, so point of tangency. Okay, this little mark here means segment, IE. So let's check that out. All right, here's segment IE. It's from here to here. That's a chord. Line CJ. Line CJ. Let's see. Okay, I see C right here, and J is over there. So this is a common tangent. It stays outside of the circle, so this is a common external tangent, as opposed to this will be a common internal tangent. Okay, so CJ is a common external tangent. Okay. Is LKJ a major arc? Guess we should be doing this then. A major arc, minor arc, or semicircle. LKJ. Let's see. LKJ goes from here all the way around to here. That is a major arc. It's bigger than 180 degrees. Okay, you can see if I did a diameter, it would be like that. So this is bigger than 180 degrees, so major arc. Okay, what about arc GEC? Okay, let's see. G E C. And you see we got a diameter happening right here, so that is definitely a semicircle. Okay, determine whether segment AB is tangent to circle P. Well, a tangent is always going to be perpendicular. So if this is a tangent, then this should be a right triangle. So let's use the Pythagorean theorem and check it out. So if this is a tangent, 5 squared plus 8 squared should equal 11 squared. Just putting a little question mark on it because we don't know. So, but let's see. 5 squared plus 8 squared. I'm just going to do it. I'm going to do it on my own calculator. I'm going to trust that you can type it in yourself. All right, 5 squared plus 8 squared. That gives you 89. And 11 squared is 121. So these are not equal. So that means this is not a right triangle and this is not a tangent. So for number 8, the answer is no. For number 9, again, we're checking to see, is this 90 degrees? So if so, this should be a right triangle and the Pythagorean theorem should hold. So let's check 7 squared plus 24 squared and see, is that equal to 25 squared? Okay, well, so what was that? 7 squared plus 24 squared. All right, that is 625. And then meanwhile, 25 squared is also 625. Okay, so we got 625 equals 625. So the Pythagorean theorem is true. That means this is a right triangle, which means AB is tangent to the circle. So we will say yes for number 9. Okay, number 10. Solve for x. Segments that appear to be tangent are tangent. Well, like I said, if this is a tangent, that makes this 90 degrees, and we can do the Pythagorean theorem. So x squared should equal 7 squared plus 12 squared. Okay, let's see. 7 squared plus 12 squared. That is 193. Take the square root of both sides. Square root of 193. Okay, so that doesn't simplify. So x is the square root of 193. Now in decimal form, that is approximately 13.89. All right, now where's number 11? All right, same type of deal over here. If this is a tangent, then this is a right triangle. So that means x squared plus 10 squared should equal 25 squared. So it's x squared plus 100 is equal to 625. Subtract 100 from both sides. That gives me x squared is equal to 525. Take the square root of both sides. Let's see, the square root of 525, and I get 5 radical 21. All right, the decimal form of that would be approximately 22.91. Okay, so that's number 11. Let's find number 12. Where is number 12? Oh, it's this stuff over here. So I guess it's referring to this triangle. We got some diameters. All right, arc ET is up first. Arc ET. So we're supposed to be finding this right here. Well, this is the central angle. So the angle and the arc should have the same measure. These are vertical angles, so if this is 55, then this will be 55. Excuse me. Which means the arc will also be 55 degrees. Okay, so 55 degrees. Number 13, arc SF. All right, let's see. Arc SF. Well, hopefully you can see that this side of the circle over here, this is a semicircle. Okay, so that's a total of 180 degrees. So we can just do 180 minus 90 minus 55. Okay, and see what we get. Okay, that is 35 degrees. All right, and that's the angle and the arc. So arc SF is 35 degrees. Now what about angle EMS? Okay, angle, hello. All right.
Until the next period, since I come here.
Yeah, that's fine. I miss you too, sweetheart.
Have a good day.
I'll see you soon. See you soon. All right, this is angle EMS. And as you can see, I already found that this was 55. So I just got to do 55 plus 90. All right, 55 plus 90. That gives us 145. All right, for the yellow angle. Okay, I just forgot what I already said. 145. Okay, now how about arc TFE? What's happening there? Okay, TFE. Okay, well that's a big arc. All right, let me just redraw a little bit. Arc TFE goes from T to F all the way around and back to E. All right, that's the entire circle except for the 55-degree part. So I could just do 360 minus 55, and that would do it. So let's see, 360 minus 55, that is, well, I didn't need a calculator for that, 305. Okay, angle SMU. Okay, SMU. All right. Angle SMU is this angle over here from S to M to U. Okay, so if we consider this portion of the circle, that's the part that we're talking about. So we already found the 35 before. So it's just the 35 plus the 55. And of course, all together, that, whoops, I said all together, that makes 90. All right, 90 degrees. Okay, how about angle EMU? EMU. Okay, EMU is this angle right here. Well, what happened to yellow? All right, EMU. Okay, so we're talking about this part of the circle. All right, so how many degrees is that? Well, hopefully you can see that what we have here, wow, that's ugly. Let me bring that back. Hopefully you can see that what we have here is a semicircle. All right, so say if I look at this part, see that diameter? So these two together should add up to 180. So that's one way to look at it, is to add these up to 180, subtract from 180. So this should be 180 minus 55. Okay, so that's going to be 25? I mean 125. All right, obviously. So that's what EMU is. Okay, that takes us through number 17. Okay, where's number 18? Point I is the incenter of triangle ABC. Incenter. Remember, the incenter is equidistant from the sides, by the way. So, which segments are congruent? Justify your response. Okay, so point I is the incenter. So the incenter is equidistant to the sides. So that means this distance and this distance and this distance will be equal, all right, because those are the distances to the sides. Okay, so EI, FI, and DI. And for a justification, we can say let me change colors. The incenter is, all right, pardon my sloppy handwriting, is equidistant to the sides of the triangle. All right, still on number 18. Given that IF is 4 and IB is 5. Let's see. So IF is 4. And IB is 5. Centimeters. What is the measure of angle FIB? Okay, FIB. Wow, so this is really a review question, okay? If I want to find the measure of this angle, I'm going to need a trig function. Okay, so looking at FIB is this angle right here, okay? Because it goes like this. It's like FIB. So if I want to find this angle, from the perspective of this angle and understanding that I've got a right triangle happening, 4 is adjacent and 5 is the hypotenuse. Adjacent and hypotenuse. Well, that is the cosine function. So the cosine of, and I'll call it theta, I'm going to call this theta right here. The cosine of theta should equal 4 over 5, adjacent over hypotenuse. So if I want the angle, I need to use inverse trig function. So I will do inverse cosine of 4 over 5. So don't forget your trigonometry, I guess, because you never know when it's going to show up. So in inverse cosine of 4/5. Okay, so I will do second cosine of 4 over 5. That gives me 36.87 degrees. Okay. Part C. Given that the measure of angle EAD is 56 degrees, let's see, I got to get that down. Okay, EAD is 56 degrees. Okay, so EAD is that angle up there. All right, so this is 56 degrees. Okay, all the way across that angle. The double angle is 56 degrees. Now, what is the measure of angle EAI? Interesting. EAI is this this part of it. All right, EAI is just the green part. Now, an incenter is where the angle bisectors meet. So these are angle bisectors, which means that AI is dividing angle A into two congruent halves. So I just need to do 56 divided by 2, and that's going to be 28, I do believe. So that is 28 degrees. Okay, point J is the circumcenter of this triangle. Which segments are congruent? Circumcenter. Well, the circumcenter is equidistant from the vertices. So the following segments should be all the same. All right, it's the distance to the vertex, the distance to the vertex, the distance to the vertex. All right, so JX, JY, JZ. Okay, and for our justification, we will say that the circumcenter is equidistant from the vertices. Okay, given that xy equals 14. Okay, so xy is 14. So this whole thing from here to here, 14. And uj is 10. Let's see. So uj, okay, I'm going to clean this up a little bit. All right, here's uj, and we're being told that that is 10. Okay, and so we're supposed to find the length of jz, which is right there. So let's find the length of hj, and then that should be the same thing as jz because of what we said earlier. Well, first of all, the circumcenter is formed using perpendicular bisectors. So that means this green segment is a perpendicular bisector, which means these two sides should be the same. So 7 and 7. Okay, so this triangle is 7, 10, and I'll just call this x. So I'm going to do the Pythagorean Theorem. So x squared should equal 7 squared plus 10 squared. Okay, that's x squared is equal to 149. And then I take the square root of both sides. Let's see if that simplifies it all. Square root of 149. Nope. Okay, so that is the answer. I am going to find the approximate decimal, hitting my toggle key. That is 12.21 inches. Okay, again, we were asked to find jz, but don't forget that jz is this. Okay, and I gotta change this color. And that the circumcenter is equidistant to the vertices. So all three of these lengths are the same. So since x is one of those, once I find x, I'm really finding all three of these lengths. Okay. Part C. Given that xy is 14 and uj is 10. Okay, so x, y is 14 and Wait, is this the one I just solved? Oh, okay, so same situation, but this time they're asking me for angle UXJ. Angles again, okay, UXJ. UXJ. All right, so this is another little review situation. Okay. All right, so this is the angle UXJ, is this angle right here. So once again, we're going to need the trig function. All right, from the perspective of this angle, we have, well, we really could either do opposite over hypotenuse or adjacent over hypotenuse. We have both. I'm going to use the 10 though. So opposite hypotenuse, that is the sine function. So I'm going to say the sine of the angle is, let's see, what was it? 10 over x. Oh, wait. That's too many variables. I guess I will have to use the x that I just found. So I don't want to say 10 over x. We found that x was the square root of 149. All right, notice I'm not doing the decimal form. I want all of the accuracy I can get. So instead of saying 10 over x, I'll say 10 over the square root of 149. Okay, so to get the angle, I need to do the inverse sine function. So this will be the inverse sine of 10 over radical 149. So second sine, 10 over radical 149. So that is 55.01 degrees. Okay. All right, I'm going to do this one more problem, and then I'm going to stop this video and do the rest on another video. A real estate developer wants a movie theater to be equidistant from busy town, lazy town, and crazy town. Should he use the circumcenter or incenter? Okay, well, busy town, lazy town, and crazy town are vertices. So we want the one that's going to be equally distant to the vertices. So is that incenter or circumcenter? That's the circumcenter. Okay, so the circumcenter, the incenter is equally distant to the sides. So if I wanted it to be equally distant to the highways, then I would have said incenter. But because I said the towns, that's the vertices, so I'm going to say circumcenter. So circumcenter. Because the circumcenter is equidistant from the vertices. Okay, that is going to be the end of this lesson, this video, this part. This is part 1. Part 2 is coming. So we have we have another half of the review still to come. So join me back on the part 2 video. I'll see you then.